Since I'm absent today, I'm going to be giving you guys some notes online. Please make sure that you are taking detailed notes in your notebook and copying this down, just like a normal lesson. So this is for Algebra 1. Today we're talking about nonlinear functions, and discrete or continuous graphs. Discrete graphs versus continuous graphs. Okay, so let's start off. We're going to graph some nonlinear functions. I got a couple examples for you. The first example is graph y equals the absolute value of x minus 3. Now, first thing we got to notice what these absolute value symbols mean. And that we're first taking the absolute value of our input, and then we're subtracting 3. So, couple things. Just like with the linear functions, step 1 is still going to be create table of values. Create table of values of values. Now, the cool thing is for here, for our table of values, my recommendation is just to pick negative 2, negative 1, 0, 1, 2. And just a couple things, I need you to notice here that since we're taking the absolute value of x, we call this an absolute value function. Value function. So let's go ahead and do this. My values are going to be negative 2, negative 1, 0, 1, and 2. Give yourself some space so you can actually work it out. Plugging in the numbers, I get negative. We're taking the absolute value of negative 2 and then subtracting 3. When I'm taking the absolute value, I'm asking how far is this number from 0? Well, it's positive 2 spaces away from 0. Minus 3. 2 minus 3 gives me negative 1. Next, I'm going to go ahead and plug in the value negative 1. The absolute value of negative 1, it's 1 space from 0, so that equals 1. Take away 3 gives me negative 2. Next, the absolute value of 0 minus 3, because that's what I'm plugging in for my input value. The absolute value of 0, that's 0 spaces from 0, so I get 0 minus 3, that's negative 3. Next, take the absolute value of 1 minus 3. 1 is 1 space from 0, so that gives me 1 minus 3, which is negative 2. And then last, I'm going to have 2. Take the absolute value of 2, subtract 3. The absolute value of 2 is just 2. Take away 3, gives me negative 1. Now, after I have my table of values, I'm going to come over here, and step 2, we're going to graph. Okay, here we go. Make sure that you scale your graph equally. So I'm gonna make sure it looks nice and equal. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. Let's go ahead and plot our points now. My first point is negative 2, negative 1. Negative 2, negative 1. My next point is negative 1, negative 2. My next point is 0, negative 3. Then 1, negative 2. And then 2, negative 1. Now, I can definitely tell this is non-linear because we have this graph here. I'm going to go ahead and I'm going to connect my points, draw an arrow through. And notice that my graph looks like a V. All absolute value functions will have this general shape. They'll look like a V. So it's non-linear. This is an absolute value function. So no matter where the absolute value function is on the graph, it's still going to look like a V. The next example is we're going to work on a quadratic function. So if you need to pause, rewatch, go over things, write down a question you have for me, go ahead and do that. You can also text the question to me over Remind if you'd like to. All right, so example 2. This is one of my favorite ones because a lot of students tend to make mistakes when they plug in the values here, so make sure that you're not making that mistake. Graph y equals x squared minus 5. Here we go. So let's go ahead and do this. Or actually, let's make it 2x squared minus 5. To do that, we're just going to pick -2, -1, 0, 1, and 2. So step 1, still make a table of values. All right. Include your process column, 2x squared minus 5, and I have x, and then here y. So I'll pick -2, -1, 0, 1, and 2. Oh, I didn't give myself enough room there. Let's go back and fix that. Give yourself space between so you can show the work. Now, when you evaluate, you need to use parentheses. The first thing, I need you to see when you have 2 next to this x squared, there is a multiplication sign in between. So same thing up here. There's a multiplication sign between this 2 and this x. So I'm going to go ahead and plug in -2 for x squared. The way I do that is I'm going to write 2 parentheses -2 squared minus 5. Now when you evaluate this, you have to be consistent and you can't just evaluate it any old way. You got to use order of operations. So first, do the exponents first. -2 squared on the side, that means -2 times -2. We learned that in Summer Bridge. -2 times -2, that's a +4. So then this -2 squared becomes a +4. And then take away 5. Next, 2 times 4 is equal to 8 because multiplication comes next. Minus 5 gives me 3. The next x value I'm going to choose is -1. So I'll have, when I put it in, I'll have my 2. Then you put parentheses, -1 squared minus 5. Do some work on the side. -1 squared means -1 times -1, which is a +1. So this becomes 2 times +1. Minus 5, that equals 2 minus 5, which is -3. My next x value is I'm going to choose 0. Plug it in, I'll have 2 parentheses 0 squared minus 5. 0 squared just means 0 times 0, which is 0 minus 5. That means 0 minus 5 gives me -5. Next, I'm going to plug in 1. 2 times parentheses 1 squared minus 5. You always got to use parentheses when you evaluate. Means 2, 1 squared just means 1 times 1, which is 1. 2 minus 5 is -3. My last one I'm going to choose is 2. So now I have 2 times 2 squared minus 5. 2 squared means 2 times 2. So that's 4. 2 times 4 minus 5 is 8 minus 5, which is 3. I now have my ordered pairs. I'm going to go over here, and for step 2, I'm going to graph. Here we go. So make a quick graph here. Y and X, make sure you label it. Five, six, 7, 1, 2, 3, 4. So my first ordered pair is -2, +3. My next ordered pair is -1, -3. My next ordered pair is 0, -5. Then I have 1, -3, and 2, 3. I'm going to go ahead and sketch it. This time it's going to look more of like a U. It's not a V. It's more like a U. We call this a parabola. A parabola. And then take a look over here. back in the original function, I had an x squared. Whenever you see the highest exponent on a variable is squared, you know that it's going to look like a parabola. This is called a quadratic function. The graph of a quadratic function is a parabola, so we got a u right here. Last one. We're going to go ahead and we're going to do one more function. I have graph y equals negative x to the third plus 2. Okay, now same thing. Step 1 is still going to be make a table. Probably going to want to choose those same x values. Now, a couple things. The way I need you to see this is when you have a negative out front, the coefficient is actually 1. So this actually means negative, like you should actually rewrite when you have negative x to the third plus 2. This means negative 1 x to the third plus 2. So you actually got to like rewrite the 1 there, because anytime you just have that negative out front, you could also put a 1 after the negative. So in my rule up here, I'm going to write a negative 1. Now, thinking back at the last example here, when I just had a 2 next to my x, there was a multiplication sign in here. The same thing goes right here. Between this negative 1 and this x to the third, there's a multiplication sign, so we have to write it in there. Choose the x values, negative 2, negative 1, 0, 1, 2. We're going to go ahead now and plug in those values. The way we do that is still use parentheses. So I'll have negative 1 times negative 2 to the third power plus 2. What that means, negative 2 to the third power means negative 2 times negative 2 times negative 2. You're multiplying negative 2 times itself 3 times. Negative 2 times negative 2 is positive 4 times negative 2 gives me negative 8. So I have negative 1 times negative 8. Next, negative, and then bring down your plus 2. Negative 1 times negative 8 is 8 plus 2. That gives me 10. Notice how I'm giving myself a lot of space in the table to show work in case I have to. And I want the same from you. Second, we're going to go ahead and plug in negative 1. So I have negative 1 times negative 1 to the third power plus 2. Write out this portion right here on the side, just like we did over here. This means negative 1 times itself 3 times. Negative 1 times negative 1 is positive 1 times another negative is negative 1. So I have negative 1 times negative 1. That gives me positive 1 plus 2, which is 3. Next, I'm going to go ahead and plug in 0. So I have negative 1 times 0 to the third power plus 2. 0 to the third power just means 0 times 0 times 0. So that's just 0. Negative 1 times 0 plus 2. That's 0 plus 2 or 2. Next, plug in 1. I'll have negative 1 times 1 to the third power plus 2. 1 to the third power means 1 times 1 times 1, which is just 1 plus 2. Negative 1 times 1 is negative 1 plus 2 gives me 1. Last, I'll have 2. Negative 1 times 2 to the third power plus 2. 2 to the third power means 2 times 2 times 2, which is 8. So I have negative 1 times 8 plus 2. It's negative 8 plus 2, which is negative 6. So chances are people are going to have a lot of errors here, making errors with negatives. So you got to make sure you show all the work, and then just know that when you raise something to the third power, it means you're multiplying it by itself 3 times. Let's go over to our graph now, step 2. Y and X. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. 2, 3, 4, 5, 6, 7, 8, 9, 10. 1, 2, 3, 4, 5, 6, 7, 8. 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, my first order pair is -2, +10. 1. It's right here. My next ordered pair is -1, +3. Then I have 0, 2, 1, 1. Oh, I made a mistake, I think. Where did I make a mistake at? Oh, that should be, sorry, I plotted that wrong. That should be 0, 2 right here. 0, 2. That was right there. And then now here, 1, 1 is right here. And then last I have 2, -6 down here. So now I'm going to go ahead and sketch my curve. All right, this is what we call a cubic function because I'm raising x to the third power. This is a cubic function. And they'll have this general shape. So it's not linear because it curves, but it's a cubic function because we had an x to the third power. Summarizing, back over here we had a quadratic function because I had an x to the second power. All right, and then up here I had an absolute value function because I had taken the absolute value of x. All right, that concludes